Basic forces acting on a frisbee in flight. The flight of a frisbee is influenced by four primary forces: lift, gravity, thrust, and drag. Lift is the upward force that counteracts gravity, allowing the frisbee to stay in the air. Thrust is the force applied by the person throwing the frisbee, propelling it forward, while drag works against its motion, slowing it down. Gravity pulls it toward the ground. How the spin affects stability. The spin of a frisbee plays a crucial role in its flight stability. As the frisbee spins, it creates a gyroscopic effect, which helps maintain its orientation. This spinning motion makes the frisbee more stable in the air, preventing it from tumbling and allowing it to fly in a controlled, predictable path. The faster it spins, the more stable its flight. The role of lift in frisbee flight. Lift is generated due to the frisbee's shape and the angle at which it is thrown. When a frisbee is thrown, the air pressure on top of the disc is lower than the pressure beneath it, creating lift. The curved shape of the frisbee, like an airfoil, allows air to move faster over the top, creating this pressure difference that helps the disc stay aloft. Angle of attack and flight path. The angle at which the frisbee is thrown, known as the angle of attack, directly impacts its flight path. If thrown with an upward angle, the frisbee will gain altitude before gradually coming down. A downward angle causes it to descend quickly. The right angle is crucial to achieving a smooth and controlled flight, with the most efficient path being slightly upward. Thrust. How force is applied to the frisbee. Thrust is the initial force that gets the frisbee moving. It's applied through the motion of the thrower's arm. The speed and direction of the throw determine the frisbee's initial velocity and trajectory. The faster the throw, the more thrust, and thus, the longer the frisbee stays in the air before gravity and drag slow it down. Drag. Air resistance slowing the frisbee. Drag is the force that resists the frisbee's motion through the air. It slows the frisbee down as it travels. The smoothness and shape of the frisbee's surface influence how much drag it experiences. A flat disc with less aerodynamic design faces more resistance than one with slight curvature, which helps reduce drag and improves its flight distance. The importance of aerodynamics in frisbee design. The shape of the frisbee is designed for optimal flight. The flat, wide shape helps maximize lift while minimizing drag. Additionally, the raised edges of a frisbee create a stabilizing effect, ensuring the disc flies smoothly without flipping over. This aerodynamic design ensures a steady flight, even at high speeds. The frisbee's glide and curved path. A frisbee's glide through the air is influenced by both lift and drag. After it's thrown, the frisbee follows a curved path, initially rising as lift takes over, then gradually descending as drag slows it down. The combination of these forces determines the frisbee's glide distance and the smoothness of its path, often resulting in a graceful arc before landing. The effect of wind on frisbee flight. Wind can significantly affect a frisbee's flight. A headwind, wind blowing directly against the direction of the throw, can increase drag and reduce the frisbee's range. On the other hand, a tailwind, wind blowing from behind, can extend the frisbee's distance by giving it extra speed. Side winds can also cause the frisbee to veer off course, requiring the thrower to adjust their angle. Spin, stability, and the frisbee's lift off. A frisbee's flight is uniquely governed by the combination of spin, shape, and aerodynamics. The spinning motion increases its stability, preventing erratic movements and allowing for longer, more controlled flights. Understanding these principles of physics, how lift, drag, thrust, and spin interact, helps players perfect their throws and master frisbee flight dynamics.